My name is Lachlan Barclay. I'm a software developer at Rome to Rio, a travel website, and we make it easier for people to get from A to B. And this is our website. This is what we do. You say, I want to go from here to here, and it says, here's your options. Here's how to get there quickly. Here's how to get there cheap. Here's how to get there if you want to spend a lot of money. And that's it. That's a great site, great company to work for. Instead of the usual blah, 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 you know, who I am and blah, 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 who cares? I just thought I'd cover quickly 3 awesome things that I would like to share with everybody that I think are fantastic. This one is a podcast. Do I see someone nodding? Does anyone else listen to this podcast? Does anyone listen to this podcast? No. 3 Bean Salad podcast. Hilarious. 3 guys from the UK. Unreal. I love it. If you're looking for a good comedy podcast, check this one out. It is the best. Enter the Gungeon. Does anyone play Enter the Gungeon? 1 guy. 2 guys, 3, 4, unreal, 5. Great game, Enter the Gungeon. I've been really getting obsessed with this. Check it out. It's a bullet hell roguelike, and it's really cool. Have you guys finished it? Have you guys unlocked the gunslinger? No. I'm almost there, but not quite. And last thing is something called Zwift, which is online bike riding. This is about as nerdy as it gets. When you become a middle-aged man, you feel compelled to strap on Lycra and ride your bike, and I've been doing this online because my dad's really into it, so it's really good fun you can ride virtually with other people and you can race and you can train. Are there any Zwifters here? Awesome, add me. I think my name's Lachlan Barclay on Zwift. All right, so if you want to know how to speed up your app, I'm hoping for lots of audience participation here, people, so please yell out, get involved, let's make it fun. This is the stuff that's going to be slow. So I've tried to come up with, this is like, if you want the 5-minute version, there you go, done. Once you figured out what all these are, then you can leave, go do another talk or something. So what are these icons? Come on, yell them out. What's the first one? What? Yell. Disk access is very slow. What's this? Next one. Oh, you can't see my pointer. What's that? Databases. What's that? Garbage collection. Yeah. Mirroring, looking in a mirror. Reflection is really, really slow. If we had like a bit of string and we were like joining it together. String concatenation, thank you very much. That's meant to be exceptions and errors and stuff, that's slow. That's a bad icon. Network access, network is always slow. Threads, very good. Memory, allocating memory, deallocating memory, and this is a really bad one, no one's going to get this, but it's meant to be like CPU, no, it's a bad, you won't get it. It's meant to be like collections and, anyway, I couldn't come up with a good one. If you can come up with a better one, so that's what's slow. So if you're doing all of these things, it'll probably be one of those things. But the thing is, which one is it, right? It could be any of those 10. It could be lots of other things as well, but it's probably one of those 10. So what you need to do is figure out what is actually slow. And this is the big mistake that everybody makes. They look at their code and go, it's doing these 10 things. It's doing reflection there. That'll be what's slow. I better fix that and optimize it, right? Don't do that. Before you do that, you need to prove that it is definitely the slow part in your application. So a couple of good starting points. Now, I've broken my own rule, which is to have bullet points on slides. I hate bullet points on slides, but whatever, who cares? My apologies. No, I'm not going to apologize. Bullet points, yeah. So you try to think to yourself, is the whole application slow, or is just a few different pages in your application? I come from a web app background, so if you're actually doing a console app or a data processing app or a native Windows app or whatever, sorry, my examples probably won't quite apply, but you'll figure it out. So is it just certain pages or certain bits of functionality that's slow? Is it just users that are complaining that it's slow, or does it slow down after a certain period of time? The users one is really difficult because they won't give you, enough information, but often it's when I do this, it's slow, or when it's at this point in time, it's slow, or after I use it for a certain amount of time. Try to get out of them and try to watch them do it if you possibly can. So a really good place to start is to look at your production stats. So if you don't already have production stats, if you don't monitor how the performance of your existing things, it's going to be really hard to figure out what's slow. So set that up if you don't already have that. You don't need permission to be awesome, just do it. It'll save you so much time. I've used a solution using a library called Prometheus and Grafana.
and just spitting out metrics and capture them every second or 10 seconds. And you can get a really good idea really good. We use a tool at Roam to Rio called Datadog, which I love. It's unreal. It's really expensive, but it's really great. But just as an example here, we can see we've got two endpoints. One is to fetch a shopping cart, and the other one is to update my details. And we can see they're both receiving about the same number of requests, but the total CPU time for getting my shopping cart is 1 hour, and the total time to update my details is 2 days, CPU-wise. So that's not cool. That's probably slowing down my app. I mean, we can also see that on average it's taken 280 milliseconds and that one's taken 7. That's another good place to look. But look at your performance stats. If you don't have them, set them up. Alternatively, is your slowdown actually not particularly tied to an endpoint? And is it just happens here? So yeah, we can see it slowed down at 1 a.m., slowed down again at 4 a.m. Maybe there's a scheduled task that's been kicked off then. Maybe you've got a super user who's going in there and running some horrible query, some background processing job that's going on there. You need to start having a closer look. Could be that. Handy tool is to figure out what happened first. So we can see here that we had a slowdown right here at just, 10 to 4 maybe? And then looking at our graphs, we've got, hey, there we go, quarter to 4, 10 to 4. What happened? Our requests doubled. That'll be it. Okay, we need to throw more. We could just throw more CPU at the problem. But instead of diving in and trying to fix the code, we can actually go, oh, code's actually all right. It just slowed down. But what can be really, really useful is if you zoom in on your graphs and go all the way in, and what you're trying to find is the smoking gun, the thing that sort of kicked it all off. What's happened in my experience a lot of the time is that we can see, there's a slowdown that happened at this time, and then we can see that, this thing happened at the same time. That must be the problem. So the slowdown happened right here, and thread started to escalate, and so we must have a threading locking problem. But it might have been just we ran out of memory, and suddenly we're doing heaps of garbage collections, and it's causing our threads to go crazy. So having a look at all your different stats, CPU, memory, threads, everything, and trying to find what came first. You always want to try to figure out the thing that's kicked it off. So it's very, very easy to get mislaid and misleaded into thinking that that's a problem. There, we can see threads has gone up. It must be that. I'll explain that interesting picture in a sec because I want more audience participation. But let's talk some of the likely culprits. I've lost 2 people already. Sorry, guys. Bye. I want to get them back now and say what was wrong. That was good. So yeah, likely culprits, third-party dependency. Once you start looking at these things that are slow, these are the things in my experience it'll probably be. A dependency, code that's doing more stuff than it needs to. I see this a lot. So code that's just, it might be allocating a bit of memory and it might be doing it inside a loop, and it probably doesn't need to happen inside the loop, just pull it out. That happens a lot. Allocating too much memory. There's a really handy technique using object pools. So if you're in a loop and you're allocating a string inside that loop and you're doing it 10,000 times and trying to clean up that string, you could declare, say, an array of 100 strings up front and then just loop through them. Saves you a lot of GC. I won't embarrass. I've got someone here who can probably correct every single thing that I say, but I won't pull him out. Where is he? Is he somewhere? He's hiding. Not using async await. Yes, that is definitely a massive performance killer. If you're doing synchronous blocking, don't do that. Use async await. That'll speed things up. And people trying to get clever. Oh man, the amount of times I see performance problems in code and you have a close look at it and somebody's trying to solve a problem that's already been solved, especially in when there's a Microsoft or a way to do it in the framework. Sorry, I'm a .NET guy, so all my examples are all Microsoft and .NET. People trying to get clever, too clever, and trying to multi-thread stuff, and they end up doing a deadlock and blocking by mistake. Happens a lot. And reflection. Reflection is a real performance killer. But trying to be clever. Oh yeah, participations. I figure if I go Lachlan's, you can all yell out handy hints, right? As soon as you see that thing. So can we all practice it? Lachlan's. No, louder. Lachlan's. It's pretty weak. Okay, cool. So finding the culprits. To figure out what is actually slow, there's lots of tools out there called profilers. Visual Studio has one. And what it will do is you run your program and it'll in this case, 1,000 times a second, it'll look at what line of code your current application is running.
And from there, you can go, this is the one that's taking up most of the time. We need to fix that. So I've got a little sample program here. We're going into a loop 100,000 times, and then every 100 times we're throwing an exception, and then every time we're concatenating a string, and then when we do catch that exception, every 100 times we allocate memory. So looking at that code, what do you think's slow? It's kind of three options here. We've got throwing the exception, we've got string concatenation, or we've got the memory allocation. Who reckons throwing the exception? Cool. I mean, it's not a trick question. Like this, I'm just using this to illustrate a point. Who reckons string concatenation? Okay, about double with string concatenation. And who reckons allocating memory? And about the same. So string concatenation has the win. Good job. Well done. Give yourself a round of applause. Round of applause. String concatenation is not cool. I was quite surprised, actually, that it was that high. So I run the profiler, and I say, show me how often each line of code is run. And it came up with a string profile with a string concatenation. But what if we change our application so that instead of 1 every 100, we're throwing an exception 1 in 2? So the loop will go from 1 to 100,000. When it's 0, it will throw an exception. When it's 1, it won't. When it's 2, it will. 50% of the time. And then just to make it more interesting, instead of doing string concatenation, I've turned it into using a string builder, which is what you want to do if you're doing lots of string concatenations in a loop. Concatenation, joining two strings together. And then same thing when we're catching an exception, we're allocating memory. So should we do guessing things boring, right? Who cares? Yeah, really interesting. This was on my machine. 10% was throwing the exception. I actually thought this was going to be the main one. But allocating the memory, 72% of the time. The sample rate isn't great. You see it's only caught it 173 times. So I probably want to run that for a bit longer to make sure it's not giving me a false positive. That's a big gotcha there. But my whole point is use the profiler. Profilers are awesome. Don't guess. Don't try to do it yourself. If you try to use a stopwatch, if you try to use datetime.now, I've done it hundreds of times and you'll get really misleading results, but this will tell you what's going on. You can do it locally on your machine and you might think, it's not production, but it's all relative really because you're just trying to find the main thing that's slowing down your app overall. Let's not do that. That's the stupidest idea I've ever had. Let's not do that. So a couple of tips on doing your profiler. You need to be able to run your application in a release build. So I've come across heaps of code bases that have if debug, then the code does this. If it's released, then do this. Not cool, please, for everything, get rid of that and try to move it into features that you can turn on and off if you're doing a debug or a release. Because when you're doing your profiling, it needs to be a release build because the optimizer can change the performance of your code if it's a release versus a debug. So don't run the profiler against a debug run, and don't run it while you got the debugger attached as well. Or do you? No, yeah, you do. So you want to try to simulate production traffic as close as possible. If you're hitting your API endpoint and you're so at Rome to Rio, we calculate how to get from A to B. If I'm only ever testing the calculation that calculates how to get from Melbourne to Sydney, it might show me this block of code is slow, but actually when we calculate how to get from Paris to London, has to search, flights, and the train network's very different. Is heaps bigger than Australia's, and it'll run through different code paths. So make sure you're trying to mirror as closely as possible what your production traffic was doing when it was slowing down. Run the profiler for at least 30 seconds. Don't just run it for 3 seconds and go, yeah, you got a great profile. Run it for 30 seconds, a minute. You'll probably get pretty good. And ignore startup as well. So your application startup does a whole bunch of things. Don't start collecting stuff yet. Wait till your application is running. And if possible, if you know the endpoint that's running, even stick it into a loop and then profile it and run it over and over again. You'll probably get a better idea there. Oh yeah, like I said, don't try to do it yourself. You'll just cause no end of pain. They're not super accurate. Lots of things can throw it off. Use Profiler. Sorry, Microsoft, the Profiler is really good when it works. It doesn't always work. So if you try it once and it crashes, just try again. It normally does work. Restart Visual Studio, then it'll probably work. But you might try it twice and it doesn't work and you just give up. But it is good. And shut down all of your other applications. If you're running, Slack and you got Chrome open and you got 20 tabs open and they're all doing things, they might throw things off when you try to performance run because something might happen at the same time as when you're running your performance check. So you can also try to do this on a dedicated server, can be another handy way to approach it. And skip application startup, that's good too. All right, so that's profiling. I'm going very fast. Feel free to take photos because I'm really just sort of blabbing at you. Hopefully all the useful stuff's there. Instrumentation. If you've got an app that's really big, you didn't write, or you got lots of people working on it, you might not know how often all of your functions are actually being called. So you might look at this and go, this is slow, we need to fix this. But it turns out that this function was actually being called 1,000 times, and you actually thought it was only being run once or twice. So you might see that this is the slow bit, I need to profile this, but that whole block might be just being run 100 times and you don't realize it. So you can use instrumentation, which goes through all of your methods, functions, and Visual Studio or your profiler will tell you how often these things are actually being called. Really, really useful to get a bit of, if you can assume that you know how the thing works, but this can be great. As soon as you see this and you can go, that function's been called 100,000 times, that's something you want to fix. Memory analysis. I just realized I didn't start my timer. I have no idea how I'm doing for time. That's okay. Memory analysis. So you might have, you might not know what is actually, where all your memory is being allocated. So in Profilers and in Visual Studio, when you run your app, you might have seen this window, the memory usage, and you might not have paid it much attention. But what you can do is click the Take Snapshot button, and then you do something in your app, take another snapshot, and then it shows you how many new objects have been created since and how much memory they've all taken up. Really, really handy, especially to do it to verify that actually nothing has been allocated when you run a function that you expect to do nothing. You might be surprised. And it gives you this. It goes, here's all the things that are being allocated. That might be a problem if we're doing one of them. This is all internal stuff because I just did it on that little test app. But you'll see all your own functions and your own, objects and classes that are being allocated. Perfview, where's David? Where's David? There he is. So there's a guy here. Do you want me to single you out, David, or you want to hide? He wants to hide. So there's a great tool called perfview. Does anyone use it? Does anyone use perfview? That's what it looks like. No one. David uses it. So this is an awesome tool. It is a Microsoft tool, probably initially only ever meant for internal use, but they put it out there, which is great. It's the very definition of a UI designed by a developer. That's exactly what will happen. But there's lots of great videos out there to show you how to use it. But oh my gosh, it's hard to use. But it will give you really, really low-level detail. It's really, really handy. If you can learn how to take a stack dump and analyze a stack dump, and I'm still learning how to do this, but it shows you internally what's going on as well. So when I ran it here, we can see that string builder dot append. There should be a percentage right here showing you how much it's actually using up. And we can see there's the internal exceptions being thrown. But sometimes you might run this and you might see internally it's hitting system.reflection. And you go, that's not cool. Or it's using an old, an old JSON library that's, known and slow that needs to be fixed. That's all I'm going to say about perfview. David, do you want to stick your hand out and say if anyone wants to know more about perfview, talk to that guy? No, I won't do that. .NET counters. So perfview was kind of Windows only. Well, I should say that events are kind of Windows only. And then when they brought out .NET Core, they said, this needs to run on Linux and Mac. So we need to make it cross-platform. So we can't use the old perfmon tool Windows app, which is what I used a lot. And so they've replaced it. There hasn't been an awesome replacement for perfmon and analyzing and monitoring .NET Core metrics. Has anyone actually got one? Has anyone used one? No, nah. So there you go, Microsoft, get on it. Perfmon it just shows you the graph. I just want to see a graph, that's it. You can see it in Visual Studio, but it's a tiny little graph and you can't save it and you can't see the scale and it's really annoying. Anyway, .NET Counters is a little command line tool you can run and it shows you hopefully useful stuff. That can be great just to run locally. So I'm running, monitoring one of my own applications and it's showing me that these exceptions have been thrown that many times. Shows you GCs, shows you a bunch of really nice stuff. That's kind of the new tool You can do that locally, or you can do that inside your app as well. Thank you very much, Bron. 22 minutes, awesome. Roughly, that's cool. So that will help you get those metrics. Another way to figure out what's going on in your app is to take a dump. So you can open up, how we used to do it in in Windows land, is open up Task Manager, and you can bring up your process list, and you can right click and say take dump. And it'll take a massive dump of the memory state of the application as it is right of now. So as an example, we had a problem where our app was just sometimes completely hanging and Threads was just going bananas and we had no idea what was going on. And we took a stack dump at that moment in time, and then we copied it off the production server, opened it up in Visual Studio, and we could see we had all of these threads were all trying to find and filter a hotel list. And they were just sitting there doing nothing. And there's your problem. Great, we got a locking problem there, fix it. Really, really handy learning to take a dump when that problem is happening, or just as that problem is just about to happen. Very handy tool. And then you can open it up in Visual Studio, and it will group together all of your threads that are running in your application, and you can see, we've actually got 10 threads that are currently doing this, instead of sort of seeing this list and trying to work out what the majority of your threads are actually doing if they're blocked on something. There's a window in Visual Studio called Parallel Stacks that will group together threads that have the same stack trace. Really, really handy. That's great to have. All right, so that's a bunch of hopefully useful stuff. I just really want to get across to use the profiler to find slow things. This is a really great article I can recommend. If you just Google ASP.NET Core best practices, that'll give you a huge list of 30, 50 things to do to make your app good. It's really, really nice. And once you sort of get a bit of an idea, that will help sort of inform your profiling. Because once you've seen a profile that it's doing some reflection or something that this article says don't do this, you'll have found it. That's a really nice article. Has anyone read this article? Does that ring a bell? That is a really, really old article. It's like 2006, like it's ancient. It's a bit hard to find, but I've created a short URL. And the phrase "at a glance" is the biggest lie ever written. It's like a book, I'm not exaggerating, it's like 20 chapters, but it's actually still really holds up. It's really, really good. Check that one out. And then for async, doing async await, which is just so complicated and such a headache, David Fowler's got a great article on gotchas and things to do and things not to do. There's another guy online called Stephen Cleary. Stephen Cleary, is that his name? Yeah. Who literally wrote the book, the O'Reilly book on async and await. And online on Stack Overflow, there's lots of arguments about async and await and how to do it right. Just look for the comment from Stephen Cleary, and that's what's right. Just ignore everyone else. The guy's just a legend and can explain things pretty well. Yeah, he's good. Whew. Okay. That's how to hopefully give you a bit of a pointer into finding the problem. So how do we fix it? How do we prove that we fixed it? Here's a bunch of ways, techniques. Delete code, that'll definitely speed things up. Minimize disk access. I'm serious, when it comes to fixing up code, deleting is the answer. Minimizing disk access and network access. Optimize your database queries. This is not a database optimization talk. I think there was one earlier. Yeah, was it good? Cool. Indexes, yeah, it's probably your database if you've got a big database. I won't get into that. Runtime exceptions, fix them, stop depending on exceptions. Exceptions are meant to be exceptional. Use the right collections. I really, really, really hate delayed execution. Does anyone think delayed execution is awesome? I just don't like it. Get rid of it. It makes it so much harder to find and troubleshoot performance problems. That's just my 2 cents anyway. Remove reflection. Use string builders if you allocate concatenating strings in a loop. Use for loops, for each. I think they've just improved for each in array iterations in .NET 10. Did anyone see that? That looks really cool. But yeah, bog standard for loop instead of doing a for each where you have to create an instance of each thing that you're looping through. Good old for loop can be good. Use async await. Check out some of these new things. There's the value task instead of just using task for everything. That can be really handy. Caching, we'll talk about that in a sec. get rid of custom code, there we go, and use the framework where possible, especially .NET Core. I mean, .NET Framework is great too, but the guys who have written the algorithms in the framework, it's a pretty good chance it's going to be better and faster than what you could come up with in a day. That's a good place to get started in. Everyone got a photo of that one? Yeah, cool. Reflection. I'm trying to remember why I had this slide. Oh yeah, does anyone know what reflection is? Put up your hand if you know what reflection is. Put your hand up if you're brave enough to not. It's perfectly fine if you don't know what reflection is. Okay, so cool. So reflection is when you're doing stuff at runtime that is probably done at, you would hope to be done at compile time. But here's like if I'm fetching a person from a database, getting back a person object, printing out their name and age. But if I was a psycho, I could write some code that instead of hitting .age, I could say, fetch me this property that exists on this object that is called age. So that's not type safe. I could misspell that age 2, and then this thing will be null. But a lot of libraries actually do this behind the scenes. And then I can say, okay, so that's the property that belongs to this person. Now that I've got the property, please get me the value of that property from that instance. And then that'll give you the same thing. But this is very common. Newtonsoft JSON did this for every deserialization, whereas the system.text.json, the Microsoft one now, I think caches all of it, only does it the first deserialization. So much better for performance. It's great. So that's reflection. Don't do that if you can help it. Yep. If you find someone who's doing that, just, smack them for me. Async await. Async and await will solve a lot of your performance problems as well. Don't do these. If you see any code, somebody's calling .result or .wait or creating a new thread or trying to create a new thread using their own custom task, whatchamajigger, don't do that. Don't try to be clever. You have to do async and await all the way up the chain. You have to do that. Has anyone spent weeks implementing async hell, going all the way up the chain and changing all their functions to be async? We can have a cry together, and yeah, it's painful. But it is worth doing. It will fix your performance problems, your threading problems. 5-second version of that. So if you've got a function that looks like this, and then let's say I'm calling getPerson, which is synchronous, which means the thing is just sitting there waiting to get the data back from the database. There's a good chance that there's an asynchronous version, which means that while the code is currently sitting there waiting to get the results back from the database, that code or that thread can be reused doing something else more important instead of spinning up a new thread, which is slow and can be a performance issue. When you do this, please do this, please do this. There's 4 things you got to do. Stick the async. You have to always return a task. Call it async on the end. Does anyone disagree with me? You're allowed to disagree. Nah, okay, you disagree, that's cool. But do it, it's all in the framework. It just makes it obvious. It means that you can catch when somebody has accidentally called this function and forgot to put the await keyword before it, and it just means you can lint your code a lot quicker. Yep, do that, and then make sure you use your await keyword. Do all 4 things. Don't just do 3 or 2, please. Thank you. Okay, so let's now actually discuss how to prove that we have fixed the problem. So we've got our function, we've put this change in, we've optimized something, we've gone, this is a bit slow, we should use a different collection or get rid of the reflection or whatever. There's a great library called benchmark.net, and you can give it 2 different functions, and it will time how long they take to run. But it will do all the clever stuff for you. So it actually runs it hundreds or thousands of times. It discards any outliers. It does all the profiling, not the profiling, the optimizations, and tells you on this computer, on this CPU, this is how long this function took, and it gives you a really, really good example, a really, really good number that you can trust. Where I find it the most useful is to get your function and go, well, I reckon concatenating a string here is really slow, so I'm going to try to change it to use a string builder and then compare the 2. So there's an example, string concatenation in this case took 14 seconds, string build, nothing. This thing is great. So as soon as anyone says, I've improved the performance of this code, we no longer do this, you say, show me the proof. And unless you're doing that, it's a real guess. Because if you're just using your profiler, you might fix the slow part of your code, run the profiler again, and it'll just tell you that something else is slow, but you haven't really proven that what you've actually fixed is definitely faster. And by default, it doesn't tell you actually how much memory that function is allocated, but I definitely recommend turning that on because, I mean, there's just no comparison. You can see it's allocating a crazy amount of memory. Great, use a string builder, awesome. Caching. Caching fixes all your performance problems. It's a great, awesome Band-Aid solution. It definitely has its places, but it does open up a lot of can of worms. The expression, only two difficult problems in software engineering, which is naming things and cache invalidation. After having, started to dive into really having good caching, I now finally understand what they were talking about. It will improve the performance, but yeah, just beware of a bunch of stuff. It's all about the cache hit ratio with your caching. You might think, great, let's just chuck everything in the cache, but if everything in the cache is unique and you're never pulling anything out, again, you're wasting your time. So you really need to be analysing your cache hit ratio and the size of your cache and the size of the objects that you're putting in the cache after you've released it. Don't just implement caching, turn it on, put it on production, yeah, it's fast, awesome. It's probably not, or it can probably be faster, or there's probably different solutions you can use for your caching, however you're doing it. Caching can open up another world of concurrency issues. Now suddenly if your API or your thing is returning cache data, it might be out of date and something else doesn't realize that that code is now cached. What are you going to do then? Not fun. And if one is depending on the data being reasonably up to date or working in a certain way, yeah, you might discover horrible concurrency issues. And cache invalidation issues, yes, you will definitely run into that. Just be wary. There's lots of great different cache invalidation strategies. We do our best to try to figure out what's going to be the most, what'll give us our best bang for our buck. I've found that just trying them out in production is the best approach. And you'll see very, very quickly which one sucks and which one's good. A new approach is a better approach that I should probably recommend, so I'm a cowboy, is have a mirror of your production setup running on a prod-like instance or on a dev server or whatever. Send it a little bit of traffic, production traffic, and then you can try looking at your cache and see how it's looking in there and try changing your different caching strategies to see if that'll improve performance. Oh, don't have enough room on the screen. But with caching, it's all a trade-off. Your performance problem might not be CPU. And caching is really just chucking more stuff in RAM. But these days, cloud RAM is expensive. So be wary of that. Maybe it's actually better, or actually just better scaling up CPU and giving yourself more CPU. Multi-threading, it can be good. Keep parallel for each is unreal and will speed things up and make it really, really nice. You can give it a collection of 10,000 things and you can say, please loop through this and please parallelize it. I've got 4 CPUs, make it run faster. But it will only work for stuff that's CPU bound. If it's all thread bound, then that's a waste of time. If it's a web app, try to avoid it. We really have a no multi-threading rule at Rome to Rio because you kind of want to leave it up to the web server or the load balancing or the scaling out to do that kind of stuff for you instead. But if you're doing, you might be calling an API that's slow and you want to do 3 at the same time, maybe that's a good approach. Could be good. Make sure you tune it if you are going to do multi-threading. Does anyone do parallel for each and actually make use of it? Yeah, a couple of people. Okay, cool. So yeah, it's a good approach. I found a really useful project that I was doing was generating PDFs. So we had to generate, 500,000 PDFs, and it was taking days. And we could sort of throw parallel for each and put them into batches and make use of the CPU. Yeah, it was really handy, really cool. Like I said, it might be easier to scale out instead of scaling up, and thread safety with multi-threading. Ooh, be careful. Adds a lot of complexity. Make sure you got your senior devs there ready to review your code. And it makes debugging really difficult. Man, trying to debug multi-threading issues. That's what I wake up in the middle of the night crying about. Yeah, not cool. Async awaits. I think I actually pretty much covered this. Sorry, did anyone want to take a photo of that one? Yes, no, maybe. Cool, awesome. See me afterwards if you want to know or if you've got any questions. Async awaits, the 5-second version, creating new threads is slow, especially when they're blocking. So you want to reuse them. So use async everywhere. I mentioned all that. Yeah, the JetBrains have a profiler. Has anyone used the JetBrains profiler? Yep. Is it good? Seems awesome. Not bad. Okay, cool. It seemed to handle async stuff much better than the Visual Studio one when I last used it. So if you've got a real nasty problem, definitely try to get a license and give it a crack. Scaling, I did mention. So you can spend your life optimizing code and trying to speed things up, but it might be cheaper and easier just to get more CPU or RAM. It feels like a real cop-out as a dev. You want to make things go fast. You want to make 100% usage of the thing. You don't want to waste allocating RAM, but you got to be pragmatic. Just throwing more RAM at the problem. If you're hitting a RAM ceiling, if you need 5 gig of RAM, don't be afraid, give it more RAM, things will be okay. You need to solve the underlying problem, so hopefully you won't need 17 gig of RAM the next time. But and then the other option is to break it down and scale it out instead, which is a better approach, but it requires probably more engineering work. I thought I might mention a library called Hangfire. Does anyone use Hangfire? A lot of people use Hangfire. Awesome. Yay, good. Not good, hate it. Anyone else, please? It's your own experience, yeah? Did you like it? Not bad? Good? Nah. Yeah, I'm on the fence as well. It's really good. It's very powerful. It means that you can it's great for running offline tasks. So I mentioned before the application that I had that would generate lots and lots of PDFs, and previously that was all done within the web application. So you go and try to create a background thread, and it just got messy pretty quick. Hangfire, you can sort of say, run this long-running job, and then it will store it in a database, and you can hook up multiple instances. In this case, I've only got the one server, but I could have 10 servers running, all listening to that queue, and it'll pick up jobs that you've put onto that queue and spread them out across multiple servers. So it can be really good. If you are going to use it, you need to be really careful about locking, because it's very easy for it to accidentally pick up the same job twice. And it does weird things like automatic retries. Like if it throws an exception, if your code throws an exception, it'll just run it again. And it'll just go into a loop and just keep running it if your code's deterministic, which you hope it is. But it does solve that really nice problem of we've got something that's kicked off from a web application that might take 5 or 10 minutes to run. Check out Hangfire, could be a good solution. So I think you need to ask yourself the question, what are you actually optimizing for? If you're trying to make your code go faster, are you actually just trying to make the response time of your application quicker? Maybe the problem isn't actually slow CPU. Are you actually just trying to reduce CPU usage, just squeeze more out of your CPU? Same with RAM. Or actually just trying to reduce costs, cloud costs. They're all different reasons and things that you're aiming towards. And sometimes when you're talking to other devs, they do this performance improvement and they fix, some RAM allocation, and and the problem is actually CPU. So you might be talking at cross purposes when it comes to optimizing stuff. I'll just give 5 minutes on load balancing, or probably 1 minute on load balancing, because it's easy to confuse load testing with profiling. So load testing is all about trying to figure out where your application will explode. So we're trying to hit it more and more requests per second. So at 2 requests per second, it was pretty fast. 6, it was still all right. 10, you're trying to find this spot where suddenly I'm running 12 or 14 requests a second and it's slowing down, and it'll probably just go up like that. That's what load testing is. So you want to run your app on a server, hit it with gradual increasing load, and then see where it slows down the most. Load testing, it's really, really easy to accidentally confuse yourself with profiling and performance testing and load testing. Load testing is more about just trying to squeeze the most out of your server or your CPU. What you want to do is get to the point where you can run a load test, see what the result was, which is the blue line, fix up your code, run another load test, and you can see, great, I fixed the scaling problem here. We can run 14 requests a second, and it's still responding pretty well. That's a 5-second version of load testing. That was a very, very, very quick overview of load testing. I use a library called nbomber, which is pretty good. There's the ancient one that's been around absolutely forever. Apache JMeter does everything under the sun. There's one called Web Surge, really nice, written by a guy in Brisbane, I think he is. I think that's right. That's really nice. I've used that. And I just read an article the other day, a Microsoft article, where they were recommending that one. Bombardier. It's meant to be pretty good. Anyone recommend anything else that's good? Sorry? K6. Oh yeah, I've heard of that. It's a good. nbomber is now paid. When did that happen? Oh man, that's not cool. Really? Oh man, not cool. Okay, JMeter it is. Yes. Load Ninja. Load Ninja, another good recommendation. Thank you, people. I've run out of time. Load testing tips. Take a photo if you want on my handy load testing tips. This is the most useful bit of advice because everyone does this. I do this. You fix it and you run it and you're like, it's not any faster. I'll just run it again and hopefully, I'll get better results. Don't do that. You're trying to find the truth. You're trying to definitively know if your thing is, you prove that it's faster. That's such an easy mistake to make. Yeah, I've done that. It's such an easy psychological trap. And check your standard deviation as well. If that's super high, something's going on, you need to fix it. Optimization trade-offs. That'll do. Cool. Okay, we're out of time. Thank you very much, everyone.